Welcome back. My name is Jack Burgess. Today I want to talk about styrene. I've been using styrene for a long time. I first got started, I think, back in the late 60s, early 70s. Al Armitage did an article, a good article on styrene. No one was using it at the time. He was a designer for Revell and did all their building kits, designed them. And in the article, I remember that he was talking about scribing lines using a dental tool that he reground, and you would pull it down to create this little V groove. And I tried that, and it just did not work for me. So I think I gave up on it. I met Brian Elderby in the mid-70s, I think, and he started Evergreen Styrene, or Evergreen Scale Models, in 1977. And as soon as he came out with his line of styrene, the strips and so forth, then I was gung-ho. Right now I've got about 100 structures on my layout, all scratch built. Probably about 70% of them are styrene. The ones that are not tend to be ones where I was going to use paper to simulate bricks, so I made the building out of wood so I can glue the paper on, that kind of thing. So first thing I want to talk about is materials. I mentioned Evergreen. That's all I use. They have plain styrene like this in various thicknesses. They have clear styrene in 10 thousandths thick. This is 40 thousandths. This is the primary thing I use for buildings. It's thick enough that it'll stand up. You don't need reinforcing, and it's still easy to cut. 60,000, then you're starting to have problems cutting it. I'll probably cut that on my table saw if I had 60,000. This is also 40 thousandths. This is some of their scribe styrene. They have various specialties, shiplap and so forth, and different thicknesses, of course, and different widths of the V-grooves. They also make one specially for box cars, which is 3¼ inch V-groove. That was the standard for wooden box cars. And everybody used it, so if a car came in on your railroad and there was some damage to the side, they would have the wood to replace and fix that problem. The 3¼ inch V-groove is also turned the other direction. So this one, V-grooves are going this way. On the one for boxcars, they're going this way because you don't need a long sheet. You need lots of sheets because a boxcar would take about that much. So good stuff. They also have strip styrene, and they actually have it in a couple variations. This is dimensional. This is 125 by 250, so 1/8 of an inch by 1/4 of an inch. They also have 2x4s and 2x2s and 6x8s and so forth in strips. They also have angles. They have angles. This is 90 thousandths angle. They have I-beams and so forth, all available in styrene, and they're reasonably close to scale width and thickness. Okay, this is what I use to store my strip styrene. I talked about this in my video on getting organized. It really works out well. I have all the sizes across here, and I can look down for my workbench and see which drawer I want to pull out. So I use this system right here for my dimensional styrene, which is 40 thousandths by 0.25 and so forth. And so all of the 40 thousandths is in one tray, and these are labeled. This is a 40 thousandths. I got a lot of this when I was doing some models for Proto 48, and there are also sizes, for example, 15 thousandths I've got, but there's not an equivalent 15 thousandths in 1x4s and 2x4s and so forth. So there's situations where I use this still. This might be a good way to start out sorting all your styrene. Maybe all the 1x's are in one drawer, all the 2x's, 4's in another, 6x's and so forth. I mentioned this also in the video on organization. This is how I keep track of my styrene, either plain styrene, sheet styrene. And I have another drawer or case just for scribe styrene. So what I do on this one is, for example, here's 15 thousandths. This one's been opened, and behind it are 15 thousandths unopened. So all the little pieces go in this one, and this looks like I used up a whole one, but that way again I'm not cutting stuff out of big pieces all the time. If I need a little piece, I always start with what has already been opened. If I don't find what I want there, then I will take one behind it. Tools that you need for modeling with styrene are pretty simple. You need to be able to cut it, and X-Acto knife is the right tool there. I'll show you the need for razor blades. I don't cut with them, because you're really pushing down and you're kind of losing control. So I prefer an X-Acto knife to cut with, and I'll show you when you need this. Tweezers, I've mentioned tweezers before. Anytime you're picking up small stuff, you need a good set of tweezers. A good set of squares is also, I think, essential. I've got two machinist squares, a small one, a larger one. I also have a regular carpenter's square. What I do is anytime I'm cutting styrene, if I'm cutting it off of a virgin piece that I haven't cut off before, I will always use a square, so that you know that the edges that are there when you pick it up the next time are square. If you just take something, or you hold a skid ruler and just make a cut, next time maybe it's off just a little bit, you cut everything out, and then you suddenly realize you've got a gap because it wasn't square. So different sizes. This is to go across an entire sheet. This is for a little bit smaller and smaller. These are no longer available, but this is a really cool little tool. This is not styrene. This is something else, I think. But Russ Simpson was a professional model builder, and he came out with these. And I'll show you what I use these for also. But you can make one of these yourself, obviously. Another tool that I use with styrene modeling, especially when cutting strips, is a chopper. You'll recognize this one as a very old, this was one of the original design of the choppers. And I've made some modifications. If I pull this off, you can see the problem that the knife blade over years goes through the styrene and cuts into the wood. And that kind of screws your cuts up. So what I did is I took a piece of 40 thousandths styrene, put it under here to raise the blade up by 40 thousandths, and then made a new surface to chop on, which goes right here. And so now the blade is back level again. And the first one of these I did lasted maybe 15, 20 years, and it finally broke through. Then I have over here, here's the stop to set how long of something you want to be chopped. I'm a nut for tools. So when the new chopper came out, I had to buy one, and I didn't like it because these little swing out things were kind of a pain. It had a little thing that went back and forth. So what I did on this one, this is a regular little thing you can get from the hardware store, and that sets it. You don't sit there and turn this around and back and forth. So I still tend to use this other one a lot, but this makes this one much easier. So both of them are within reach. Sometimes my workbench is so cluttered that I don't have room for my chopper. So if all I want to do is make a square cut, I don't care how long it is, whatever, then this is one that'll do it. And it doesn't take up much room. It doesn't chop real big stuff very well. You notice I had to kind of push down on it. But for 20, 30,000 stuff, it works really well because you can just pull it over, make a square cut, and as I said, I always cut everything square, even strip styrene. I will not cut it with a razor blade. I'll use my chopper. So this might be considered the ultimate chopper. It's a custom-built design because many, many, many years ago, a fellow sent me a large chopper that had to be 2 feet square, but it was really built well, and you swung around, you could do angle cuts and square cuts and everything, but it was so big I didn't have a place to put it. So I kind of set it aside, and when I was thinking about it one day, I remembered this part of it, and so this thing takes care of your strip. You're not screwing something down, just like that. This assembly is available from Northwest Short Line as a separate unit. I think they cost $6 or $8 or something. He sells them separately. The base itself is acrylic that I got from Tap Plastics. And acrylic will not, you can't glue styrene to acrylic with MEK. So I use a special acrylic glue to glue the fence on. But for long pieces especially, this works really well. And the length was set up based on what the longest pieces of styrene I would ever cut. If you were an O scale, I would make it 2 feet wide. So this worked out pretty well. Now I'm going to talk about cutting styrene. The method you use is score and snap. And let me demonstrate. I'm using my square. This is a piece of 40,000 styrene. And I hang it over the corner of my workbench because you've got to get this out of the way. So you make a mark, pencil mark, whatever, and do kind of a light cut. One a little heavier, the other one a little heavier, and that should do it. And then snap, and you're done. I mentioned earlier a razor blade. When you get finished cutting this, you'll end up with a real slight burr. And so either pull or go either way, and it's gone. And it's only going to be on the top surface. It won't be on the bottom surface. But you want to get rid of that, and you could go just very, very lightly, and you'll get rid of it. So I also want to talk about gluing styrene together. This is what I use. I want to make sure I'm not going to run out of MEK, and I've got another 1.5 gallons in the layout room. But I don't use that much. I'm just paranoid about losing what I want to use. So I use MEK. It's not carcinogenic. And when I checked many years ago, testers was MEK and some stuff to slow it down. I went online trying to find out what it's made of now, and I couldn't find it. But I like MEK because it flashes off really fast. And I'll show you what I'm talking about. Let's get a piece of styrene up here. And with MEK, it needs to be in a bottle. You do not want to have a bottle of MEK open on the workbench and applying it with a brush, because you don't want to smell the fumes. When I fill this little bottle, I fill it from a little bottle that's a little bit bigger, and I only keep that much in. That's as much as I will put in this bottle. If I overfill it, it will come out too easy. So I'll show you what I'm talking about on speed. Got a piece of styrene. You hold it where you want it. Put a drop on each side, and right there it's flashed off. So it's glued in place. I am not a very patient modeler, so I like the fact that this goes really fast. It does not give you time to reposition things. So as you saw my fingers on here, you have to have either you can clamp things where you want them, or hold it, or put a pair of tweezers on it, and then just add drops along the edge, and capillary action will pull it right underneath. And I don't know if you can actually see, it's a little glossy right there. I paint with Floquil. When Floquil was going out of business, I did exactly the same thing I did with MEK. I bought a whole bunch of Floquil. I still have unused bottles. With Floquil, you won't see that. I'm not sure if you're painting with acrylics, if you would see that little gloss. I don't think so. It's a gloss. It's not, the surface is not changed. But if you do put some down and put your finger in it, you will see that. And you can sand it off, but you're not going to be able to fill it with paint. So I should mention my bottle. These are A-West bottles. The husband and wife that owned A-West both died in a car crash maybe 10 years ago now. I'm not sure when. But as soon as I read that, I went and bought more bottles. What happens is the bottles, after having MEK in them, they will eventually start cracking. And this one I probably have had since you can't even read what was on it. I probably had this for 10 years now, and it's still doing fine. What'll happen is it won't crack and spill, but suddenly I will smell the MEK. And then I'll look at it and say, oh, time to switch bottles. So the needles that these guys have, they have different sets. This is somebody else's needles. I use the smallest one they have, which is a 16 thousandths tip, and that works. Now, these guys are out of business. I went online and I could not find a source for these now. There is another company that makes bottles just like this. Their tips, this might be their tips, but their tips are not as small. What you could do, and I've done this and it works, is get the smallest tip they have and put it in a vise and just very slowly smash the tip down so it has a very small opening. Because what you want is, if you, you'll notice there's just a real small drip, and that's big. What I will do is I'll hold this horizontally, and you can see that the drops are getting smaller. So you want to be ready to do it, and then just go in and put a drop in. There will be times when you need to glue something to styrene, such as wood maybe, or metal. Metal isn't too bad because you can use CA, but for a lot of stuff I will use canopy glue, especially like wood. This will glue wood to styrene, and it dries absolutely clear. Another advantage in some cases is that it doesn't form a rigid bond. It stays flexible. So if you're gluing a metal part to styrene, the metal is going to expand over time, and this will take care of that. Now what I want to talk about is actually putting something together, bonding together. So I've already cut out pieces for a little building, and I'm not going to talk about that right now because there's a number of ways you can do a layout, some much better than others, and I'll talk about that in the next segment. But so let's just jump to the fact that now I have two ends, two sides, and a couple of roof pieces. And what we want to do is assemble these into a little building. One of the things to keep in mind is if you have sides that have a slope like this, the sides should go inside the end. Otherwise, if they're out here, you're going to have a gap when you try to get the roof on. So we got to keep that in mind. So we need these pieces to be square with each other. And one way to do that is to use these angle bars. You could take your building and put it like this, and take something that's square in between and glue them together, and that would guarantee that these two pieces are square with each other. What we're going to do is we're going to glue one side to one end, the other side to the other end, and then put those two together. We're not going to try to do all four sides at once. The problem with this using the square is that these things can tip a little bit, and you can see I push this up as tight as I can, but it's coming back a little bit. So a better solution is a very small angle bar that pushes up all the way through. And sometimes I've clamped these. If this was a big side, I might clamp these to it. For this small one, we don't need to. One thing I did do is I ground off the corner right here, because if we're going to put glue up here, we don't want it to run down and bond the styrene to the metal. It won't stick, but it's going to stick long enough to mess you up. So let's get these aligned. So this piece is all the way to this wall. This is up against it. And then put a little bit of MEK right there in the joint, and then just wait a few seconds. In this case, I'm going to wait a little bit longer because this is kind of a vulnerable gap. And then this comes out, fortunately. And then we can add some MEK to the rest of the joint. Let that flash off, and we'll do the same thing for the other two pieces. So now we have two pieces. We glued the end to the side, and for two of them, we turn them this way, and then simply let's put them together, and again, the sides go inside the ends, and they're going to be square. You don't have to worry about putting them square because all the sides are exactly the same. So then it's just a matter of dropping MEK down, this joint. Let that sit for a few seconds. The same thing over here. As soon as those flash off, then we'll put some more MEK down the joint. Okay, so now we have the building. I do have some roof pieces that'll go in like this, but this is going to be a building with battens. And battens are where you would have regular boards, you build the building, and then you nail a real small strip of wood over the joint to keep the thing waterproof and windproof. So the battens are going to be from 1x3s, and you'll notice I have a little clip here. That's because I will take material out of a spot, cut some pieces off, and then forget where I got it. And I've done that so much that I've thrown stuff away that I think, is that a 1x4 or is that a 1x3? And I toss it in my spares box. So this helps me put it back in the right spot. What I also do is once I've cut stuff off, I put it up on the left-hand side of the tray here so that I don't keep cutting little pieces off a 12-inch long piece of styrene, and suddenly I need a 12-inch long piece of styrene and I don't have one. So the first thing we need to do is draw guidelines for the battens. And we're going to assume that this building was built with 12-inch wide boards. So in this case, I will use my scale ruler, which I usually don't do, but we're not talking extreme accuracy here. So we'll make a pencil mark every foot. That's enough. And now we need to make lines, and this is where I use this little square that I mentioned earlier. For this process, it really works well. So, and I'm also using a mechanical pencil. This is a 0.5 millimeter pencil. It's for drafting, and it gives you a nice fine line. They don't cost that much. I think maybe $7 or something. Get a package of lead at the same time. My package has lasted me for decades. Okay, now what we want to do is cut some of these guys, but I'll cut them extra long, and it doesn't make any difference how long, just as long as they're longer than the side. And the reason I'm doing this is it's much easier to cut off the excess than to try to cut them exactly to length. There's no reason to cut them exactly to length. And they don't need to be centered on the pencil line. They can butt up to this pencil line. So we prop one in this place. That'll hold it for now. Just a drop of MEK. So that's enough to show you what I'm talking about. So these are dry now. So now you can take your razor blade, but see it's kind of hard to get in there. So these are flush cutters. You can see how thin the blade itself is. And what you can do is take these just like this. Same thing on the top. So that takes care of the battens. So for putting the roof on, I'm just eyeballing the overhangs on each side. If I was building a contest model, I would measure them and get them exactly right. But tip it upside down, add MEK to the joints. Let that flash off and flip it over and do the same thing for the other piece. So that's as far as I'm going to go on this structure. It's pretty crude, but it at least demonstrated the things I wanted to talk about. Next time, what I want to talk about will be layout, cutting out windows, some other more specific tasks.